Solving quadratic equations. So when we're solving quadratic equations, what we want to do in this case of this form is that we want to isolate the squared value first. So isolate squared value. So for example, x squared, or another example, you want like x plus 5 squared. You want that isolated, meaning you don't want any number in front, or you don't want any number added or subtracted to the back. So if we have it that's what we want to do, is isolate it. Then the next thing we want to do is, after we isolate it, is we take the square root of both sides. Take square root both sides. Okay, and that's this symbol. And then you solve for x. So remember, when you take the square root, when you take the square root, or when you square root, you get plus or minus whatever is in that square root. Okay, so there's two solutions. So this first example, we have x squared minus 100, so let's isolate this squared value. So x squared, we're going to add 100 to both sides. So we get x squared equals 100. Then to get rid of that square, let's square root. So we get x equals plus or minus, square root of 100 is 10. So x equals 10 and x equals negative 10. For 5b, we want to isolate this square, so we're going to add 27 to both sides. So we get 3x squared equals 27. Now we don't want to square root now because this 3 isn't perfect, right? If you square root it, you would be still a radical and a radical. So the nice thing is just to go ahead and divide by 3. So we get x squared equals 27 over 3, which is 9. Now if we take the square root, that's perfect. X equals plus or minus 3. Again, two solutions. For letter C, what we want to do in this case is we want to isolate this squared value here. So let's move the 8 and the 5. So first, let's move the 8. So let's subtract 8 from both sides. So we get 5 times x minus 3 squared equals 100. Then the squared value is still not isolated, so the next thing we can do is divide by 5. So you don't want to expand it, you don't want to distribute. It's going to make this problem a whole lot longer, and it's just not as efficient. So we divide both sides by 5, so we get x minus 3 squared equals 100 over 5, which is 20. Now we can square root both sides, and so that gets rid of this square. And now we have x minus 3 equals square root of 20. So let me do a little bit of work over here. So remember, square root of 20, we can simplify that. It's not perfect, but this is 4 times 5. That's prime, and 4 is 2 times 2. So remember, when you have this broken down, you circle the pairs, and that comes outside. The 5 stays inside because it doesn't have anyone to match up with. So this is square root of 20 is 2 root 5. So remember, this is a plus and minus square root, plus and minus of 2 root 5. The last thing we need to do to isolate our x is add 3 to both sides. Notice how I put a blank space in front of the plus or minus. It's much nicer to leave that blank just to make sure that we know that the 3 comes before that plus or minus here. A common error that students make is that they move the 3 to the end. So let me show you on this side what tends to happen is students do this, and then they change it to a plus or minus 3. That is not the same as x equals plus or minus 2 root 5 and then plus 3, right? So this is actually the answer, but this is what students tend to do. So I think one way to avoid that is just to make sure we have that space in front of the 2 root 5, and then we just insert it there. Just makes it nice and clean to look at, and then it just reminds us of where the plus and minus actually belongs. So I hope this helps out. Thanks for watching.